In this video, I'm going to show you the basics of making a ball and socket armature. I'm only going to show you the process of making the hips to give you some of the basics. First, we start with machining. It may seem like cheating, but we begin with the already fabricated joints. This aspect of the process is created with a CNC machine where the joints are designed in a program like Inventor. Then you design the armature from the inside out using the molds. You want to use the largest joint you can fit in the mold with room for the skin. For the hips, you want the ball of the joint to hit the line where the torso and the leg meet in the sculpt. Use a piece of clay to hold it and place out your joints in the mold. You want the joint to be placed in the center of the mold. The whole armature should be centered and not favoring one side or the other. Take a piece of square stock steel and measure out where the joints will connect. I buy my steel from McMaster-Carr online. Cut the steel with whatever resources you have. We had this great saw at the studio when I was on Pinocchio that makes really great clean cuts. You can also use a jeweler saw. Make sure the piece fits in the molds, then mark with calipers where you want to lay it down to fit the balls. The balls have holes in them at a standard size. Measure them using the back end of your calipers. I'm using a mini lathe to grind down the square stock into a round shape to fit the holes of the balls. Take this process very slow, shaving off little by little. Stop the machine periodically and use your caliper measurements from before to get the perfect fit. Your final piece will have a square part in the middle for connecting the spine and round rod shapes for the balls to fit onto. Now that you've designed this fit, you need to place another piece on top that we can connect the rod for the spine onto. Cut that down and check it in the mold for sizing. Now it's time to drill a hole into that square stock for the spine. Use parallels to hold the stock in a mini vise. I used cut down flat brass sheets instead of parallels because they are a lot cheaper. Use a spring clip between the parallels to add tension to hold them in place. Place the stock on top of the parallels and clamp in the vise. The reason for the parallels is to hold the stock above the foot of the vise so you can drill entirely through the material without drilling directly into the base. Use a drill bit that is the same size of the hole in the ball, because we will be connecting these pieces with a rod of the same size. I like to use a chip brush to sweep away the swarf. Measure the rod to the length you need and cut it down. Now we need a side rig, which I am making out of 7/32 inch brass K&S, which is the standard receiver size for a rig point. Cut the brass with a 2-inch mini bench top cutoff saw. There will be debris left over from the cut of the blade going into the soft metal, so clean it up with a mini file, being sure to hit every side so it's clear. You want to be sure that it will allow the 3/16 inch plug-in to fit inside the rig without hindrance. Side note, we are creating a side rig which allows the puppet to be suspended in the air during animation with a rig. The rig gets erased out of the background in post. Okay, back to fabrication. Scribe a line down the middle of the K&S in order to properly place the nuts that will allow for the grub screws to secure the puppet to the rig tightly. Use the nuts to plot out where they go on the K&S. You want them to land at the very edge of the stock. Use a center punch and hammer to dimple the brass. This will allow you to drill the metal without the drill spinning around the metal because it doesn't have a guide. Drill holes for a 440 grub screw to thread through, which is what we'll be using to hold the rig inside the rig point with tension. Now we will move on to silver soldering. Technically, this process is called brazing because it takes a certain higher temperature to fuse together the metals. Everyone I've met in the industry in Portland calls it soldering, and everyone I've met in LA in the industry calls it brazing. So pick your poison. Place your nuts over the holes and hold in place with helping hands on a fire brick. Apply flux to your metal. This will help heat the metal up faster while also protecting it. Put silver solder chips that you've cut down with nippers onto the fire brick. Use a soldering pick to pick up the chips. Apply heat to your piece until the flux becomes glassy. Apply heat to the metal and place the chip where you would like to bond the pieces together. Repeat this process to strengthen the silver solder bond. I like using the pick method for smaller parts of the piece like this. Remove the piece and let it cool. After it cools, you will want to let it sit in an acid pickle to clean off the oxidation and scrub it with a brass brush afterwards. Now, prep your steel bits. Place helping hands on the pieces to keep them from moving around when the flame is directed on it. Put on the flux and heat up the steel stock. I'm feeding the solder into the flame now instead of using the pick method. When you are adjoining the balls to the hips, put solder chips in the ball and place on the round stock. You want to use a vise with cut down honeycombs to hinder the heat sink the metal on the vise would conduct on the steel stock. Basically, metal takes in heat and it would draw the heat out of your piece, which is where you want the heat concentrated. Coat the piece with flux. Use a fire brick to hold the ball in place. Otherwise, the heat will build up a pressure that will make the ball pop off the rod. Watch for the silver solder to spill out of the ball onto the rod to know when it has flowed. Let it cool, and then repeat the same process of pickling and brush scrubbing off the oxidation. That's how you make the hips, and this is the beginning of making a ball and socket armature. Now it's on to the silicone casting process.